All right, thanks everybody for joining today. We're going to be having our annual tradition. Ed Colone from University of Michigan is back, and every year he usually has a whole crop of students that he's been working with on interesting Personar plugins. This year it's just one student, Jonathan Waldrep from Virginia Tech, and the topic is going to be layer 2 connectivity tools for Wi-Fi monitoring. So Ed and Jonathan, if you want to get started.
Thank you, Jason. So, Jason already introduced us. I'm Ed Colone from University of Michigan. My co-presenter is Jonathan Waldrep from Virginia Tech. And let's see if this... Okay, so a little background. The University of Michigan embarked upon a Wi-Fi monitoring project back in 2020. It's called PSSID. And the ultimate goal was to monitor our enterprise SSIDs for performance and reliability. At the heart of this, we wanted to be able to scale this to enterprise scale. So we chose the Raspberry Pi. So because it's a well-known, well-supported platform, it's relatively inexpensive. And we don't want to reinvent the wheel wherever possible. So we wanted to use commodity off-the-shelf open source software to monitor the networks once we had connectivity to them. So that naturally led us to Personar. We also wanted to copy Personar's most current 5.x data analytics stack. So we're going to utilize the same stuff they are: Logstash, OpenSearch, Grafana. And it's been an interesting 4 years. They say that experience is what you get when you don't get what you want, and that is for sure true. Wi-Fi monitoring is very difficult. It's an uncommon usage case. Most people load their operating system, fight with WPA supplicant until they're able to reliably establish a single connection to a single SSID, and then they never touch it again. Our usage case is completely different. We're constantly switching between SSIDs. And if in rare cases now, we're also going to be checking specific BSSIDs where it's appropriate. There's the whole stack is in play. I mean, you have problems at the hardware level. Operating systems don't support certain options. 802.1x is a complicated protocol with very few tools that support it. DHCP, you have an opportunity to screw up your routing table. And then on top of this, like I said before, the normal usage case is a single connection. So a lot of the operating systems ship with an intended network manager to kind of control the network interfaces, but they present an incompatibility with the type of monitoring we're trying to do a lot of the time. WPA supplicant itself is a very inscrutable tool sometimes, especially when you're trying to use it in our usage case. And on top of that, Personar doesn't always want to play well with a Wi-Fi interface. So those are the challenges we've sort of identified over the last couple of years. And since then, there's been some advances in modern technology. Personar came out with 5.x. It has the newer data analytics stack, which we're going to be using, as well as batch processing, which sort of simplifies the higher level protocol testing. We at the University of Michigan got some interest from Virginia Tech on this project. We have been collaborating with them, hence my co-presenter, Jonathan. And we have a new development cycle that we started this year. We're trying to kind of take a step back from our initial lofty goals. We're going to try to simplify the tools we're using to interact with the Wi-Fi network. We're not going to try to immediately incorporate them into Personar, which was where our initial goals were. Once we get this working on a Raspberry Pi in a manual sense, our goal is to write a Python daemon that automates it. We've developed a web interface in order to manage the entire system. And the hardest part, arguably, is the layer 2 and layer 3 tool development. And thankfully, Jonathan has come along to help us with that. So the entire system, from an architectural view, is that in the middle of this, all the heart of this, we have enterprise deployment of Raspberry Pis. They're intended to monitor the network, and they're going to send their metrics into, like we said, Personar compatible data analytics stack. So Logstash, OpenSearch, Kibana. And in order to make this manageable at the enterprise level, we've developed a GUI. So the audience being network technicians, they don't have to learn JSON. They don't have to learn about Personar. They don't have to learn about Raspberry Pis even. Once you integrate the Raspberry Pis with the GUI itself, you're able to kind of go and click through and establish test schedules, SSID profiles, uh, things of that nature. And then you can use the system with Ansible. Ansible's at the heart of that system to push out configuration as well as commands to these Raspberry Pis to essentially enforce monitoring schedules, tests in specific tests. And you can do that fairly simply without really knowing the underlying configuration syntax of all of the systems in play. So with that, I'm going to turn it over to my co-presenter.
Yeah. So the Raspberry Pi configuration. So from a high level, what we want to happen is that over the Ethernet, we're going to be managing it's going to be the management interface. It's also going to provide power with PoE. And that's going to be a stable connection back to be able to report um, to Sonar and all the different other tools for reporting and everything. So there's be the PSSID daemon that is running on the Pi itself, and it is going to schedule all the different tasks and stuff that it's going to do for the testing. And all of the analytics and everything like that will go back to the Elk stack and with the tools that already exist there. And then the wireless interface that is on the Raspberry Pi will then run the actual tests and whatnot. Let's see here, you can go to the next slide. So how do we imagine deploying these? In an ideal world, we'd have a whole bunch of these and just put a whole bunch of the pies and put them everywhere. That would give you a very comprehensive view of the whole network. In reality, that's a logistical nightmare, and that's just a lot of fiddly pieces and whatnot, and it's a lot of management overhead of that when you start talking about having that many of them. So we anticipate a more likely deployment scenario would be you have these deployed to what you would consider your priority areas. So for us as higher ed, that would be our larger classrooms, especially. And we'd expect having a Pi like in the instructor's podium. The advantage of that versus some of the other solutions that exist from like the vendors and whatnot, oftentimes they are monitoring the network from an AP, which is up on the ceiling that could be 30 feet in the air. That's not what the RF looks like for our clients. And so we want something that is representative of where the clients themselves are. So at desk level is where we would want it. Anywhere we have large classrooms, especially, hopefully eventually like one in every classroom would be great to get a good broad coverage of that. Also, you could have several on hand for when you have a problematic area. You get reports coming in of something going wrong. You can go deploy a Pi or 3 somewhere where you're getting these reports and get some feedback on what is or isn't working. And if it comes back as like, oh, okay, we're seeing that there's multiple authentication attempts that is being required or something like that, gives you some feedback on what's going on and can be used as a ad hoc troubleshooting tool that way. And the good thing is it's flexible, right? You can decide what's good for your institution and what your needs are. We did intend to, or as Ed had already said, part of the intent of deploying on Raspberry Pis is they're cheap. They're sometimes readily available. And so, and it should port well to other platforms as well. But that's the big picture, right? You can decide what works for you. So there's a little bit of a question of like, we already have a lot of tools for monitoring the network, right? Obviously, that's what we do. So why this other approach? And ultimately, kind of comes back to like a top-down versus bottom-up perspective. So playing a little game here of, is this a raging coal seam fire or is this a toaster fire, right? Is this someone set the setting on the toaster dial a little too dark. Yes, you can go to the next slide. Here's a little bar from one of our monitoring tools. This is monitoring from the top down or inside out, or however you want to talk about it, from the infrastructure side instead of imitating a client. And you see that you have like associations is 68% successful, and that sounds awful. Authentication, it's in green. It should be good, right? And it's like 82% success. It's like I think that's actually kind of terrible. Like if only 82% of our authentications succeed, that sounds really bad, right? So you can see the overall there. And you can go to the next slide. Um, so if you dig into it a little bit and you look at it, these are the association failures. We have things like the client doesn't support the authentication mechanism used. Like that's not a network problem. For the scope of this conversation, I don't care about that. Or things like, oh, it doesn't support, the authentication algorithm or the different auth settings. It has the wrong SSID configured. It's like, okay, that's definitely not a network problem. I do not care about that. And in particular, if you look at that top one, where 68% of the association failures is coming from legacy clients not supporting, if you click there, you should see it pop up. All 33,000 of those failures are coming from 2 devices. I super do not care about this problem, right? And it is cluttering up my monitoring and my ability to see what's going on. So, like, is this smoke a coal seam or is it a toaster? This one looks like a toaster, right? And so, if you go to the next one, we'll take a look at our authentication instead. Yeah, one more. Sorry. Um, yeah, so here we have the bulk of our authentication failures, unsurprisingly, is a bad password configured, which is interesting from like a service perspective point of view of like, yeah, we should probably move to ETLS and that would help clear a lot of this up and different things we can do there. But from the day-to-day perspective of, is my network down? Are things working as intended? I don't care. And that's 99% of my failures. And so it's really hard to see from that overview of like, is this actually a problem? On the other hand, that 1% of failures is timeouts. And it's like, okay, authentication server timeout. Do I care about these? Maybe. We're running Eduroam. It's an authenticated network, right? So like if my clients are timing out on my campus, that's a problem. But if it's someone from University of Michigan visiting here and we get a timeout from UMich, I care at least differently, probably a whole lot less, right? Because like those packets have a lot further to go. I'm not surprised that some of those are timing out. There's a lot more complexity there. That's a lot less of a problem. So is that a coal seam or is that a toaster fire? I'm not sure, right? Um, if you go to the next slide, you'll actually see this one's definitely a coal seam fire. This was our semester startup from fall 23. We had, I'll spare you the details. There was a problem. As you can see from the graph here, this is the first week of class. And this is the rate at which our authentications were timing out. It was peaking up to almost 80%, which is like, yeah, that's a coal seam fire for sure. But as the nature of things happens, um, timeouts are tricky to actually see because you're looking for a thing that didn't happen, which is a lot harder to find. Um, Also because of, the nature of having a problem and when the world is on fire and you're looking deeper into things than you ever are before, you do things, you fix stuff, you're like, all right, great. We hit that, so the middle of the day on Wednesday, right there in the middle of the graph, we fixed the problem. And that was, if I remember right, that was even just a guess of like, well, we implemented this thing. Let's turn that off and see if that fixed things. And yes, it did. Great. But our timeouts didn't drop to 0. It dropped to really low, right? So if you look at that tail end there, it's like, okay, we zoom in on that. Just next slide. Um, is this still a problem? Yeah, I felt a little bit like Kuzco and Emperor's New Groove. Like, yeah, I'm a llama again. Is that good though? Like, is roughly like a half to 1% of timeouts on average? Like, is that actually healthy? Like, I think that's our baseline of where we were before, but is it good? I don't know, right? And so that's where the outside in monitoring comes in. On the next slide, we talk a little bit about like, I'm sorry, it was actually 2 slides from now, but yeah. So a good point here is this is what a coal seam fire actually looks like most of the time, or a lot of the time, is just a little bit of smoke above the ground. Um, and this is actually Burning Mountain in Australia, and it is a coal seam that has been smoldering and on fire for uh, all of history. And so it is an apt metaphor in that the problems in our network that have been around the longest are also the hardest to spot. Um, and so with a lot of noise in our monitoring, it's really hard to see what's going on. And so in the next slide, I think, yeah, okay. Where does our noise come from? I already mentioned federated credentials, right? We're using eduroam. If those packets have to go from here to DC out to Michigan or all the way to the other side of the world to Paris or Japan before getting back to us, things are going to happen, right? I expect failures there. Misconfigured devices, we're in a higher ed. We have been and always will be a BYOD environment. And so there will always be misconfigured devices, and they are noisy because they try, they fail, they try again, they fail again, they try again, they fail again, and it just clutters up your data. Roaming devices, if someone is on a bus and is riding through campus and they tried to connect to a wireless AP that is inside of a building while on the bus, and then that fails because they leave the service area before they connect, I don't care. Like nobody's expecting that to work. And you see the same thing even with students walking down the street, going between buildings and stuff like that. As they are roaming and they are on that edge of the service area, I don't care if they don't connect because they don't care because they're probably on cellular at that point anyway. And it's not somewhere where we're actually expecting it to work. Versus if we have a bottom-up view, we can take this Raspberry Pi. It has a known good configuration because I configured it and I know what the configuration is. I put it somewhere where I expect it to work, where there's good coverage, and I can have it try and try again and try again and try again, and I expect it to work every single time. If there are any failures there, those are interesting, and those are help cut through that noise of the top-down monitoring. And to be clear, I'm not saying we don't need top-down monitoring. Obviously, we do. It has plenty of advantages for a lot of different views of things that we absolutely need. Um, Also, with the client side or bottom-up monitoring, we have that holistic user experience of is every step of this working, right? There's a lot of things that can go wrong that look like a wireless problem that isn't like the wireless system proper, right? So like we've already talked about authentication quite a bit, isn't technically part of the wireless system, but if it's broke, it can't get on wireless. And people say, hey, Ezreum's down. So we get to test that. We get to test is DNS working, is DHCP working, and all these other related services on the network that we need in order for a client to actually be able to get to Facebook to do what they want to do. Um, we can test all of those things, and we can test, can I ping something on the local network? Can I ping something out on the internet, right? That will suss out some of those harder to spot problems that where it looks like every piece is working, but sometimes things don't work together. Um, and so, yeah, every failure should be interesting is what we're after here. All right. So, anatomy of a test. What does it look like? It's about what you might expect of you connect to the wireless, you do DHCP, you run your layer 7 tests, you disconnect from DHCP and you disconnect from wireless. And there's the commands, so the PSSID tools that we wrote. And how these are going to work is you hand it in a WPA supplicant config, which will be handled by the GUI and stuff that Ed has mentioned already. So we're not expecting our network admins to be able to write WPA supplicant configs. That will be generated. You specify that though, you specify the wireless interface that you're going to be performing this test on. It will connect to the wireless network. It will spit out some JSON to standard out. And it's JSON because structured data is good. And it will have just some very basic things of, hey, I tried these things at these times. Here's the overall result. Talk a little bit about where the details of that come from. But then you move on to layer 3, you do a DHCP, you're going to get your v4 and your v6 addresses, and then you can run your whatever other tests we want, which is a little bit out of scope of this particular part of the talk. But yeah, we can do the pings and the DNS lookups and stuff like that we mentioned before. And then you run the same commands in reverse with a -d flag to disconnect, and that's where you'll actually get the bulk of the output for reasons I'll explain in a moment. Yeah, so that's the anatomy of a test. Next slide. One of the questions we had was network managers, right? This is something that Ed alluded to earlier. Are they helpful or are they a hindrance? On most Linux devices, they're running something such as network manager with a capital N, capital M. Are they helpful or are they a hindrance? The advantage is it is a cohesive profile for a wireless network. Disadvantage is it is a cohesive profile for every part of that wireless connection, and it's a little harder to get some information out of it. It's also designed for a human interface for the most part. There are programmatic controls to these, but that's not the focus of the tool. The tool is intended to be a human interface point, not a scripted interface point or a programmatic interface point. And part of that then also means that if there is a failure, if it can't connect for some reason, for whatever version of can't connect it decides is appropriate, um, it's harder to get the information out of that of but what actually went wrong? Was it that I was able to authenticate? Was it that I was not able to associate? Was it not able to get DHCP? Is it just not able to reach the captive portal test that it is expecting there? Um, and it's difficult to get information out of it, which makes it difficult to integrate with Perf And Ed had already, and his crew had already done some attempts of wrangling some network managers into their will, had some difficulty there. Um, so yeah, and I guess it's probably a good point to talk through like what are the steps of connecting to wireless, right? There's actually you authenticate and then you associate and then you authenticate again and then you do DHCP or whatever to get your network addresses, and then the rest of the network stack as you are mostly familiar with, right? The first authentication is the WEP authentication. Even if you're not doing WEP, obviously WEP is deprecated and it's terrible. Please don't use it. Um, but it is the first step, and nowadays it is mostly just an express of I'm going to associate to this AP of this BSSID, and so you do that open authentication. You do that, you associate, which is the actual establishing a connection to the radio that you're talking to, and then you do your .1x authentication for Edge Room, or whatever your .1x network may be, and that's where you do EAP and possibly PPMS-V2 or EPTLS or whatever variation of EAP you've chosen for your institution. And then that allows you to actually start passing traffic, including DHCP, etc. Most devices will then also do a check to see if they're behind a captive portal. They'll hit a known endpoint to see if they get the known expected response back. That can be done in the browser sometimes it's done in network managers, etc. And depending on if you expect to hit a captive portal or not, that could be good or bad. So that's the general flow that is going through, and we have replicated at least most of that in the test that we have that we just covered in the last slide of the anatomy of the test. And then by splitting that apart, we can get more details about which part of this failed, which helps us in our troubleshooting, which is ultimately what we're after. Next slide. So if we're not using the supplicant, or I'm sorry, if we're not using a network manager itself, then what is doing the connect to the network part of this, or connect to the wireless part? There's two big options, which are the venerable WPA supplicant, and then Intel has a kind of the new kid on the block, IWD, which is intended to work around some of the crufty bits of a WPA supplicant for one, and also just the Linux wireless network stack has grown organically and can have some rough edges to it. It has a tendency to expose some options that should be abstracted away and makes the administrator care about more things than they need to care about, which in our case actually is kind of a good thing, right? Because we know exactly what we're looking for and we can provide a WPA supplicant file that is exactly what we're looking for. So we ended up going with WPA supplicant. It's been around a little longer, and it's well matured and well documented. And also in our case, it's easier to get the information out of it that we're looking for. Also, we can hand it a profile or a configuration file that has a single wireless profile to it, whereas IWD is looking in a directory of profiles and then it will pick the correct one based on the SSID. And so that would then automating putting files in place and removing them as necessary. It's certainly doable, but it's just another step of things to go wrong versus we can have all the profiles we need and just point to the one that we want. So we went with WPA supplicant. Next slide. So what are some of the implementation issues of that? There's obviously a million ways you can talk to WPA supplicant. You can talk to the dbus or through Unix sockets. We're trying really hard to not reinvent the wheel, so we're using the CLI tool that has already wrapped that. I think it's talking dbus on the back end. It has an interactive and a non-interactive bit to it. So back when we were considering should we talk to every BSSID versus ESSID, interactive would be a good way to say, hey, now try this other BSSID, now try this other BSSID. Decide that's a bad reason for reasons we'll talk about in a second. But in an attempt to not reinvent the wheel and then to have a direct way to say, hey, this is exactly what I'm expecting you to do, we use the WPS supplicant CLI tool. And then we use a little bit of interactive part of WPS CLI when we go to disconnect for the most part. But if we want to get something out of it, we can do that too. Also, difficulties with the OS compatibilities. We originally started deploying this on Ubuntu 20.04, as that's kind of the de facto standard OS to be building up perf sonar stuff on, and it's an LTS release of Ubuntu. Turns out Ubuntu 20.04 does not support TLS 1.2 for wireless authentications. If you search TLS 1.2 in Ubuntu 20, it's all about how they're moving to TLS 1.2, but that's for things that aren't the authentication for the wireless network. And so if you have a Radius server that is supporting only TLS 1.2, you cannot connect with Ubuntu 20. So we moved to Ubuntu 22.04, and that has resolved that problem. And so now we're able to connect and test more things that way, which is excellent. Yep. So alluded to earlier, do we want to test each BSSID versus ESSID? For those not familiar with wireless parlance, the ESSID is like the name of the network that you see in your list, and you drop down, you're picking a network. The BSSID looks like a MAC address, and it is the unique identifier of a particular radio on a particular access point. And so it's the other endpoint for when you're talking over the air. So it would be nice to be able to iterate through all the BSSIDs that we see on the air and test each of them individually and say, is this one working? Does it do what we expect it to? Yes. Okay, great. No, we can report that back. Turns out real world clients don't do that, right? They say, in their wireless profile, this is the ESSID that I'm looking for. I'm going to use some heuristics to pick the one that I think is best, and I'm going to connect to that. And part of the difficulty here is that the infrastructure expects that the client is flexible in this manner and has mechanisms with some of the 802.11 standards, and sometimes rather forcefully can move that client from one BSSID to another BSSID, potentially on a different channel. And so if we have pinned down, thou shalt connect to this BSSID and test this one, and then the infrastructure tries and moves us somewhat forcefully, it's going to disconnect us from that radio. And then our client's going to refuse to connect to anything else, and it's going to look like a network failure, but really it's a self-induced failure. It's going to add to that noise that we don't care about, right? So we don't want false failures here. So we decided to stick with just the ESSID. That's also a truer test of how clients actually behave. Also, this is, I had alluded to this earlier. Turns out in the Cynefin model, networks are complex, maybe even chaotic, and that it is hard to know what state you are in until you go take an action and see what happened, right? It's not a simple model where it's like, I know I am in state A, I want to move to state B, and in order to do that, I must take some action Z, right? It's actually really hard to know what state A is or what state you are actually in until you try to do something. So what that means is there are a lot of things that are a success scenario or a failure scenario that look a lot alike. So going back to the network trying to move the client, if I connect to the network and then immediately disconnect and reconnect to something else, is that a success or is that a failure? It could be a success in that the network was doing what the network does and said, oh, this radio has a whole bunch of clients on it and this one right next to you has none. Move over there and you'll get a better experience. Or it might be that there was noise in the air, some RF noise or something, and the client had tried to connect, failed, couldn't pass any packets, gave up, disconnected, and tried connecting somewhere else. So those two scenarios look a lot alike. Also, some of the client-side tools are not quite as responsive as we would like them to be. DHCP-CD, it will run and fork to the background potentially before the IP address is applied to the interface. So if we check to see, hey, did I get an IPv4 address as soon as I disconnect or as soon as it forks to the background? Um, um, I lost my train of thought. Yeah, so if we check to see if that IP address happened, if we got it, um, then it may not actually show up yet, even though we've finished DHCP very quickly. And I just lost my train of thought. Yeah, so it's hard to tell, was it successful or not, right? And so we decided that the best thing to do is to not try and do an analysis of, hey, here's our logs and whatnot. We're not going to analyze those on the Pi and determine if it was a success or failure. The Pi itself is just going to say, this is what happened. Take that, package it nicely in some structured data, and hand it up to the rest of the perf sonar system for the analysis tools there to make sense of what's going on. And we can determine the success or failures there. Also, instead of trying to determine, yeah, this was a failure, or, I saw these definitive things when they happen. So like a natural or naive approach to this would be, I'm going to connect to the wireless. I'm going to report back the status of that. I'm going to do DHCP. I'm going to report back the status of that. What we actually do is just go ahead and do the whole connection process. We connect to wireless, connect to DHCP, run the other tests, and then on the teardown, when we actually report back, here's what happened, because we have more information at that point. We can get a fuller picture of what's going on. Yeah. So next slide. Live demo. All right. So this will be, if I can, I need to come over here. Let me move my Zoom window somewhere else where I won't have an infinity mirror effect. All right, share my screen. Share over here. All right, you should be able to see my screen now. Is that correct?
Yep, we can see it.
Excellent. So I've got some stuff pulled up here already. This is me SSH'd into the Raspberry Pi. You'll see run some tests, or not tests, but some information, see what the status of the network is right now. On the wireless network, you can see it's giving some information about WLAN 0. It's not telling us what SSID we're connected to because we're not connected to any SSID. IP link show. So on the Ethernet, we have a link up on the Ethernet, and the wireless link is down. Similarly, IP address show. Obviously, loopback is uninteresting. We have an address. This is just a wired connection between my laptop and the Pi. So we have a link there for management. And then on the wireless, it is currently down, which is expected. But critically, if we do an IP route show, I do not have a default gateway or anything like that. So if I try to ping something that's not on my local network, it's just going to tell me, nope, can't do it. So this is kind of the default state of the Pi. And so we will run some commands I've saved here. This to actually connect. It will print some status stuff to standard error as we're doing it, because we anticipate that as the test suites and things are being developed and whatnot, some immediate feedback is helpful. And then JSON of the output. And this is pretty printed. If we cat 802.11 start.json, right? It's compacted and whatnot, which is what you'd expect for sending something over the network. And so here we can see a timestamp of I started this applicant, it connected, everything looks happy, no obvious glaring failures at this point. And then we'll do DHCP. Ooh. There we go. It's going to do something similar, right? So it's printing standard error as it's doing things. And then we get a huge amount of output here, which I'll explain in just a moment. Mostly, again, this status code of no obvious failures. DHCP started and exited with status 0, so we can see when DHCP exits or forks to the background. Did it tell me that there was a problem? Because if so, like, I wouldn't report that. And then a timestamp with the before and after of the status of the network. So in the before, we can see we had already gotten a v6 address because the kernel does that automatically. And we have a v6 link local address, but no v4 address. And then In the after, we have another v6 address because DHCP did it, but no v4 address yet. And this is a great example of why we are collecting most of the data at the end. And so if we actually run, so IP adders show WLAN 0, WLAN 0, we do in fact have a v4 address. It did complete DHCP just fine. Also IW WLAN 0, nope, that's the wrong command. Info, right? So now we can see they're connected to SSID edge room. And then we can go ahead and do a ping, and that works just fine. We can do a ping 2606, 4700, 4700. Cool. All right, and so we have v4 and v6 connectivity. Here's where you would do all the other tests of if you want to test if certain services are up or things like that, all your layer 7 tests, etc. And then we can do tear down our DHCP. We get a similar output here of the before and after of the network state, and we also get the similar log of yep, it worked, and we were releasing the address at this time and whatnot, so we can piece things together. And we also get the DHCP log itself, which I'll come back to in just a second. But we'll go ahead and disconnect from wireless first. Same thing. We ran the same commands as before, but again, just with a -D on it. Looks like it worked. Usually disconnect works much better than connecting, or is much more reliable. And then, yeah, again, WPA supplicant log. So what do those logs look like? We can, that is a Z standard compressed and then base 64 encoded version of the log that those underlying tools actually output. I'm actually going to add that. So here we can see the DHCP log. What it looks like. It includes the timestamps, obviously, and then all the different things that DHCP is doing. And so, like I said, just reverse it through base 64 and Z standard. And then similarly on the WPA supplicant log, right? Here's everything that WPA supplicant includes. And so nice thing about this one is it also includes the certificate being presented by the Radius server. That's a common failure point, and so it's nice to have that in there. Also, if it disconnects and then reconnects or something like that, or moves from one BSSID to another, all of that will be captured in the WPA supplicant log. And then we can do the same thing. Actually, let me copy paste that. VT open Wi-Fi, and I will just do that, right? Just demonstrating that you can readily do the same tests on a different network. WLAN 0 info, and now we're connected to VT open Wi-Fi instead of edge room. And then we could do the same thing with the DHCP, set up and tear down, etc. And then run the same thing. I could type, there we go, -D, disconnecting, and there's our log. So that is the gist of it, right? And so some of our next efforts is to take this output and wrap it up and integrate it with perf sonar and not, and that is actually the end of the demonstration and a good transition for Ed.
Thank you very much. Let me try to find the presentation again. And here we are. So we've included slides on the slide deck that basically walk through the steps that Jonathan just took in the live demo. And we won't be going through them because Jonathan already basically covered that. So what are the next steps? We want to be able to crawl before we walk and walk before we run. So we're going to be doing all of this manually in the next couple of weeks. And then we're going to automate all of it. We're going to write Python scripts that basically do the entire transaction on a schedule. And like we say, that's going to be defined through the UI. It'll create config files and push them to manage your enterprise network of these devices. And then once we're sure that all of that is working, very reliably, it's our goal to integrate the L2 and L3 tools that Jonathan has developed with Personar and with PSID. So that's going to be down the road, and hopefully that'll be enhancing pScheduler, Personar's capabilities as well. We want to be able to get initial results into the OpenSearch stack so we can start to visualize and make sense of them on a human scale. And like I said, we want to integrate everything as much as possible with Personar and pScheduler to take advantage of the development that's being done there with their tools, as well as being able to enhance that product as well. And that's kind of the end of the presentation. We've got a link to the code repository for the code that Jonathan has developed, and we'd be happy to take any questions.
All right. Well, thank you guys for going through that, and glad the demo worked. Shows some really interesting stuff there. I'm going to allow people to unmute themselves if I remember how to do that. Okay, so people can raise your hand if you want to ask a question or still use the chat room. We had one snide comment in there, but we also had one other question. Are there any advantages other than licensing over something like the Aruba UXI?
Yeah, so that's a great question. There's some obvious advantages, as you mentioned, like licensing and just being open source in general. Also, this is less tied to a particular vendor. Those kind of all fall together. One advantage in particular over Aruba's UXI is that UXI is very high level in what it is giving you. It in those tools from basically any vendor tool that is for monitoring or something like that, I always end up finding myself asking questions that they aren't providing answers to, right? I'm asking unexpected questions that the vendor didn't expect me to ask. And so with a tool like this, where it's open source, I can modify the tool to make it ask whatever question I want. And you can kind of do that by offering different tests with UXI. But ultimately being able to have the logs, being able to wrangle through them myself, being able to decide for myself what is important. A lot of times with UXI and others, they're using some AI or ML to decide what is important for you. And I always find that I'm lacking context then. So those would be what I would say is the primary benefits. And those kind of all go with it's an open source tool. But there is a little bit of more nuance to that other than just yay open source. Does that answer the question?
I'll also throw in that we are using Aruba as our vendor, and we are using their monitoring infrastructure currently, but it's fairly cost prohibitive. It seems like the probes themselves are one or two orders of magnitude more expensive than a Raspberry Pi, and the licensing, like you alluded to, is also an impediment for us to anyway deploy a large scale enterprise deployment of these things. We're hoping that the Raspberry Pis remain affordable, and the software, the cost is staff time, where you have to stand it up and become proficient in deploying it and managing it. But beyond that, it's open source, and your licensing fees are obviously zero.
All right. Sounds like that answered Anthony's question. You actually hit on something I was going to ask, but I think you answered it, but I'll just confirm it. So even in the use case where there's a vendor supplied tool like this Aruba tool, or if there's one from Mist or something like that, those still rely on having to have a probe deployed to work. It's not something that's just like inborn into the APs themselves.
There's a mix there. So usually the vendors provide more than one tool. So I can speak to the Aruba side because we're an Aruba shop at Virginia Tech. You can set radios to be in air monitoring mode and collect some data that way. That is less of like I'm going to imitate a client. And usually the AP based ones, like I mentioned in the talk, like the AP's up on the ceiling, which is not where our clients are. Um, Cisco also has some things that are similar-ish. They have some integration on the driver level with Intel, Apple, and Samsung, where they can get some information out of stuff that way to get some more details about like, okay, but why did you fail? That doesn't help with like cutting through the noise of like, is it a misconfigured device? Is it a device that is on the road somewhere and it is moving too fast to connect? Because it's just getting that from all of the users, which is good and bad, right? Like you get a fuller picture, but sometimes it's too inclusive of a picture of what's going on. So it doesn't do a good job of cutting through that noise of finding the failures that I actually care about.
Okay. So I'll put out the call again. If anybody has any other questions, either raise your hand or ask them or type them into the chat room. I had one more, and I know that you're sort of probably months, if not years, away from this stage. But once it is integrated into Personar, um, what do you envision sort of the mechanism for conveying this information to the users will be? Will it be graphs? Will it be alerts? Will it be some combination of both? I mean, as I think about this, there's different ways that I would probably want to see this information presented. Have you guys thought much about this?
Well, yeah, we're going to embrace Personar 5.x's data aggregation and analytics stack. So that's using OpenSearch and Grafana. So you can make pretty pictures and use those for data analysis and, make reports and whatnot. Uh, OpenSearch itself is a very powerful log analysis engine. So like the goal is to get the very fine granular logs that Jonathan is generating that show individual aspects of every transaction. And he can break that down a little better than I can. But it's not you can look at layer two authentication as a holistic blob, or you can break it down into the sub transactions. So we're hoping that we can use Logstash and OpenSearch to set up a data schema there to break all that down, and then Grafana can display it. And of course, we would also want to set alerting thresholds. So we're just trying to, like Jonathan alluded to, gather as much data as possible and then provide an analytics engine that can make use of the totality of it. And I kind of wanted to circle back to the previous topic as well. If you're deploying a Raspberry Pi in the field, you can potentially find another use for it. If you want to run alongside this monitoring solution, you want to run something that passively looks at your, electromagnetic spectrum. That's possible. If you want to be able to just use Personar and double check your 1 gig interface back and do a throughput or a latency on the wired side of your network, that's possible as well. So it's not just um, uh, an appliance per se that has a single purpose. It's still a general purpose machine, and you can adapt it to your own needs. You could do packet captures on it if you wanted. So I'll just leave it at that.
All right. We just had a question come in from Scott. What tool did Jonathan use to see the timeout rate in definitely a coal seam fire?
Yeah. So the graph itself was Google Sheets, right? Which was a little bit of well, the data underlying data came from Splunk. So that was the logs output by the wireless controller, who would tell us like, okay, this connection timed out. And so that's where that came from. Yeah, and the graph itself could be generated in Splunk. was in the middle of a fire with what I knew how to do at the time.
Okay. Well, I think we may be out of questions, so thank you again for going through this. If one of you just wants to send me the slides, I'll make sure that they get posted along with the video. And for those still on, we do have a talk next week. James Harr from Internet 2 will be talking about some work that he's doing with IPv6 and some test infrastructure. So hope everybody has a good holiday weekend, and we will talk to everybody next week.
Thank you, Jason, for the opportunity to present our work.
Yes, thank you.
No problem. Thank you all. Bye.